In this video, we are going to look for the answers for the 2023 to 2024 ICT First Form Test Paper, Section B. So going to the Section B, you can see that they are all about the short questions and answers. So in this case, students, you need to read very carefully about the questions, what are they asking for, and also the marks distribution, for example, 1 mark or 2 marks. So it will reveal how many sentences you need to include in your answers. So in this video, we are not going to go through all of the questions because for some of the questions, I think that you can handle them by looking or reading the marking scheme by yourself, because kind of common sense and something about your experience for the technologies in your livelihood. So we will just go through some questions with some very special knowledge. So without that knowledge, you cannot solve the problems, something like that. So let's start with question 2 first. So in question 2, we have a situation. Mary is the administrator of a school. The form below is created by her to collect students' data. So in this case, you can see that underneath you have a table and you are given by 4 different kind of fields. So they are student name, gender, year of study, and also the phone number. And in this table, just next to the field name, you can see some kind of explanation. And this kind of explanation is very important for you to complete this question. So we'll talk about this later. And then we have the example. So the example is to let you know about what is going on with the requirement set in the explanation and kind of expectation, what you will receive from the user's input. So let's read through the questions next. For each field, suggest and describe a data validation method, and the method cannot be repeated. So the first thing we can think about is the data validation method. If you refer to the textbook, that should be in page 35. So you got a very good table listing out what kind of data validation methods are there. And for the next clause here, it is called the method cannot be repeated. So what does that mean? So it means that you cannot keep saying the same kind of data validation method for all the answers. So for example, A, you may say presence check, but for B, you cannot say presence check, or C or D. So you cannot repeatedly to use the same check for all the answers. So once you have used the presence check in A, for example, you cannot use it again in B, C, D, something like that. So let's have a look of each of the fields. So the first one, student name, you can refer to the explanation. So student name, it says, this field stores the name of each student. So for this case, actually, they didn't give you a very strict requirement for this field. So something like you must do this, you must not do this, something like that, right? So in this case, you can just say anything by common sense. For example, you can say for this field, we do not want to miss out the student name in our form. So in this case, you can refer to the presence check, PRE, and then SENCE check, right? So if you compare to the marking scheme, you can see it's a kind of different from the answers written in the marking scheme, but it's okay because in the explanation, they didn't really say some requirements for this field. So what do I mean by requirement? You can see the requirement in the next remaining fields. For example, the first one, gender, right? So in the gender, they have told you that only M or F can be the data input by the users. So that means the user is restricted to these 2 options only. They cannot create other answers other than M or F. So by the table, okay, if you read through the table in your textbook, you should be sure that this kind of things you need the fixed value check, because this is the meaning of fixed value. Okay, so no doubts, so easy. And then we come to the next field. It is called the year of study, so you read it very carefully. So for this field, you should have just a number. So for example, 1 represents the first year, and there's a requirement called that a student must graduate in or before his 6th year. So what does that mean? So that means the student can input 1 for his or her first year of graduation. He or she can input 2, 3, 4, 5, or 6, but not more than that. And of course, you cannot be less than 1, because you can see that we count the years one by one. So kind of 1, 2, 3, 4, 5, 6, you cannot escape from this range of number, right? So we use the word range from 1 to 6. So in this case, very obviously, we can say that we should apply the range check for this year of study field. So we can put down range check. Okay, so last but not least, for the phone number, the requirement is it must be a phone number in Hong Kong, right? So in Hong Kong, by common sense, you should know that no phone numbers should be more than or less than 8 digits, right? So in this case, you can say that it is the length check, because we need to limit the length of the user input for their phone number. If they input more than 8 or less than 8, that means the number should be wrong. And of course, you can also argue that it can be a type check, right? Because for phone number in Hong Kong, we only accept for the numbers to become your phone number. So in this case, you can also write down type check, and as long as, okay, the point is as long as your answer is making some sense, okay, some common sense, and if it does, you will receive 1 mark from the question, from this question. So easy. So this is for question 2. And then the next question, I'm going to skip a little bit of question 3. I just want to go directly to 3C. So 3C is a kind of question with a situation here. Now Johnson is preparing a presentation for his research. He is going to insert some pictures in his slides. He is going to insert a company logo and a photograph in his slides, where these 2 graphics are in different file formats. So when you read through this text or question, they mention 2 different file formats for image. You should think about the 2 different types of image. So they are bitmap image and the vector image. So again, if you just refer to your book, they are all in page 11 to 12. So if you are working on this question, you can just refer to this page. So let's talk about question C first. Given that 2 formats are vectors, they have given you already, vector graphics and bitmaps, determine the file formats of the company logo and the photograph. So when we are considering which one should we pick up, it really depends on the usage of the image. So let's write the company logo for the first line and the photograph for the second line. Okay, So for the first one, company logo, so it is obviously that it is used for the commercial purpose. So for example, you want to make a business and you want to show the logo. And of course, if you want to show the logo, you are trying to promote something to outside. And you don't expect that when somebody is playing around with your logo and then trying to resize your logo, it will have some kind of square, or we call it the pixels, coming out from the image. So because this is also a kind of image of the company. So very obvious. Company logo, we always make them into a vector image, or in the question they use the word graphics, so we just follow graphics. Okay, so they should be in vector form. And for the photograph, we have learned about the nature of vector image. Although you can say that, oh, after resizing, you won't have the squares coming out from the image, right? We still use the bitmap, because for the vector image, if you go back to your book page 11 to 12, you will see that for bitmap, for the vector, they are kind of showing the image by using simple lines, curves, circle, polygons, so on and so forth. So for vector images, they can only present some very basic shapes of the things. So in photograph, in reality, for example, you take a picture by your phone, you will see that the picture is not so simple. And in this case, if you use the vector image, it will be very complicated for the format, okay, to calculate or make the lines for your very complicated images. So the point is here, photograph, we use the bitmap image because the image will be a very complicated picture. So for question D, will the enlargement of a vector graphic make it unclear? Explain your answer. So this is very easy. 2 marks. First of all, you need to answer yes or no. So definitely no, because we know that vector image resizing won't have the squares and pixels coming out from the image. So when you do the enlargement, of course, enlargement means going larger and larger, right? So it won't make it unclear. And explain your answer. This is a kind of difficult question, okay? But you still can refer to your book. They said that the vector images are stored as mathematical formula, so you can use this kind of sentence to help you to explain. So why we do not have the unclear? Because actually you can write in this way. The photo of the graphic is made up with mathematical formula rather than pixels. You can write in this way, because why do you see the squares and things unclear? Because of the pixels, right? So we try to express the reason by saying that we made up the graphics not by the pixel, but by kind of the mathematical formulas or kind of lines, we call it geometry, okay? Lines, curves, circles, something like that, okay? So this is a kind of alternative answers for you to explain your answer. And of course, you can refer to the marking scheme. Marking scheme will give you a more explicit reason for why it won't happen, right? So you can refer to the marking scheme. So this is for question 3. So I'm going to skip a little bit part of here because you can read it by your own. You can read it by your own in the marking scheme. So let's go to question 4. So question 4 here, it is a question about calculation. So here it is a country identity code, ID card we call it, number, and it is composed of 7 decimal digits. So that's why you can see 1, 2, 3, 4, 5, 6, 7. There are 7 squares for you to fill up the numbers. In which the rightmost check digit is known as the check digit. So here it is the check digit. So check digits, you can immediately think about the example of your Hong Kong ID card. So for example, A12345 6, and then usually you have a bracket with a number, for example 7. So we call this the check digits. So let's revise what is the check digits. So the check digits is added to the end of your data. So for this part, it is called the data. Okay, in order to avoid the error coming out from your input data. So always we will say that the check digits, right, you can find it out by looking at the data itself, and then by some calculation you can find out what is the check digit. So in other words, this check digit is always fixed. Okay, it's always fixed. So you need to know about this concept because it will affect your calculation. So let's look at the first question now. A1. How many different ID card numbers can be formed in this way? Okay, so when they ask you the questions in how many ways, so they are asking you how many patterns or how many different patterns can be formed. So in the calculation, the number of patterns, we have been working out for several questions like this. So if you are trying to find out how many patterns, first of all, you need to know about for each digit, how many different options do you have. So coming back to the image here, let's write down for each digit, or we call it how many, each bit, okay, we call it each bit, how many different numbers you can fill it up. So for here, we have the word decimal digits. So decimal means that 0, 1, 2, 3, up to 9. So in total, there are 10 digits, right? So in other words, for each bit, now I will be very clear that for each bit, you should have 10 different digits, 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 and the last one, I will just keep it first because a little bit special. For the first 6 digits, you should have all these kind of options for you to choose your number. Okay, and then when we are finding the number of patterns, we have gone through the mathematical part already. You want to find out the number of ways, you will do the multiplication. 10 times 10 times 10 times 10 times 10 times 10. So which means that for the first 6 digits in your ID card, you should have 10 to the power of 6 different kind of patterns for you to form your ID. Okay, so now we have a look of the X7, which is the last digit, because it is the check digit, and if you remember that we have said this digit is fixed already, because this digit is designed for you to validate your input data, okay, to make it correct, in other words. So the digit is fixed. You cannot change it, okay? So in other words, if it is already fixed, that means you have only one option for you to fill in, okay? The only one. And you times 1, and obviously you will see that how many different ID card numbers with these 7 decimal digits now, it should be 10 times 10 times 10, okay? Times 10 times 10 times 10 times the last one, 1. So 10 to the power of 6 times 1, which is 10 to the power of 6. So here is the answer, okay? So this is A1. So A2, what is the purpose of the check digits? We have just explained in the beginning of this question. So we'll just write it very briefly. The check digits, what is the purpose? The purpose is to ensure the input number is valid, okay? And of course, you can also talk about the method by adding a digit at the end of the actual number or the data. Okay, so this is about the check digits. So you can write it in this way. Okay, so the next question will be B. So it's quite a long question, but we can read through one by one. The check digits x7 is calculated in the following way. So you can see calculated because it is a check digit. Step 1, calculate the sum of x1 to x6. So sum means the plus something, plus something, plus something. Something is going up, coming out. This is called the sum. Okay, so in other words, step 1, if you want to calculate x7, you need to add all the digits from the first one to the sixth one. Okay, and then divide the sum by 9. So that means divide means this symbol, divide by 9, and then record the remainder. So the remainder, so for example, 27 is divided by 4. You will say that 4 times 6 is 24, and then you have 3 remain, so this is called a remainder. Okay, and this comes to the remainder, you have to record it. And then step 3, assign the remainder to the check digit 7. Assign means put into. So you put that remainder into x7. So all in all, you will have these 3 steps to ensure what kind of check digits you need to include in the last digit's place. Okay, so let's come to the question now. Check whether 1, 2, 3, 4, 5, 6, 7 is a valid ID number and show all the steps in your calculation. So this number 1, 2, 3, 4, 5, 6, 7, because it is a kind of ID card number that you are testing, you need to follow the rules again. So in the question, they have already mentioned about the last digit is the check digit, and that means 7, right? This case is the check digit. Okay, so we are going to follow these 3 steps and check whether the check digit is matched to 7. If it is matched, that means it is a valid ID number. And if it doesn't match to the last digit 7, that means it is wrong. So in this case, we just need to follow step 1. We calculate the sum x1 to x6. So we have the first digit 1, and then 2, 3, 4, and then 5, and then 6. You add all the digits, right? And here the sum should be 21 by your calculator. And then we just follow step 2. Step 2, we are going to divide by 9. So put in your calculator, you will have 21 divided by 9. So you should have some remainder. So in this case, you have to do it in mind. So because 9 times 9 times 2 is 18, right? So we have a 2, this is called quotient. 2, and then after 2, you should have 3 remain, right? 3 remain, so this is the remainder. Okay, after dividing 21 by 9. So in this case, we just follow 3. Assign the remainder to the check digits x7. So because we see that after the division of the first 6, after the sum of the first 6 digits and then divide by 9, we follow the first 2 steps, the remainder is 3. So in case if we have come up with the first 1, 2, 3, 4, 5, 6, okay, digits for your ID, it is supposed to be the last one 3 here to make it valid, okay, to make it valid. But in this case, they have given you 7, so we say that because 7 is not equal to 3, so therefore the ID is not valid. So this is how the check digits works, okay? So if the calculation result is 7, of course the ID works, so the ID is valid. But in this case, we see that the check digit, okay, sorry, the remainder is 3 and the check digits is also 3, and it is not exactly the same as the number given by the question. So in this case, we'll say that it is not a valid ID. So this is question B. So We will go to the next question, question 5, kind of calculation of the different kind of units. So let's read the questions. Miu has taken 85 video files using a digital video camera. Assume the file size of each video is 40 megabytes. She wants to copy all the video files to her computer. The remaining storage space of the hard disk is 3 gigabytes. So first of all, express gigabytes in terms of megabytes. So this is again about the conversion of units. Just refer to page 58. Okay? We know that from gigabytes to megabytes because just the change of G to M, we just need to multiply the numbers by 1024 and we should get to the number in MB. So we have how many gigabytes here? We have, they just ask you to express 1 gigabyte. Okay, here because they are missing a number, 1 gigabyte. So 1 gigabyte is equal to 1024 megabytes, and that's it for the first question. So it's not so difficult. So for question 2, she wonders whether there's enough space for storing the video files. What do you think? Explain your answer briefly. So here you need to show your calculation for explain your answer briefly. So in this case, because we are given with the situation 85 video files, right? So you have this much files in your computer, in your camera, and you need to test whether in this hard disk you can contain these all videos. So the first thing is to make sure all the units are the same. So here the hard disk unit is gigabytes, and therefore first of all you need to know about in gigabytes the video files. Okay, how many gigabytes are they? Or vice versa, you can make your like a file video measure in megabytes, convert it into gigabytes. So make everything into gigabytes. In other words, okay. So just make sure all of them are in gigabytes, and then you do the comparison. Okay. So I work in this way. So first of all, just calculate the file size for all the videos. Okay, for all the videos. So this is equal to, because you have 85 files there, and each of them are 40 megabytes, you will just multiply by 40. And you should get the number 3400 megabytes, right? And of course, you need to make it into gigabytes for your comparison. So you do the division, 3400 divided by 1024, and this will become your gigabytes, and this will give you the answer 3.32 gigabytes, right? And of course, this one is already over the 3 gigabytes that your hard disk has contained. So therefore, you can explain it is not possible. It is not possible. Okay, so the point is you just show your steps. Okay, show your steps. Okay, for your explanation. Okay, so that will lead you to the full marks of this question. Okay, so for question B, I'm not going to talk about this because kind of from your experience or something like that, you can read it in your marking scheme. So let's go to the last question, question 6, all about the conversion. Still, we are in page 58, okay? So let's do it one by one. 52 kilobytes to bits. So we have involved the unit kilobytes into bits. So look at the table, you should find out that we need to do something called 52 times 1024, so that it will become the bytes. And then if you want to change from bytes to bits, you multiply by 8. So all in total, you should have 425984 bits. And of course, for this question, they didn't ask you to show your calculation, so you just write down the answer is fine. But for me, I just want to show the step to you. So you just do it here. You can see it here. So for question B, convert 36B in hexadecimal into the corresponding binary number. So if you put in your calculator, of course, you will see that there's an error because the binary number, the length should be longer than the bits that you have in your calculator. So in this case, you have to apply the technique once again. Make them into just piece by piece. We'll do it piece by piece. So in your calculator, if you just put 3 into your calculator and 6 into your calculator, B into your calculator, and turn them into binary, you should get to the correct answer. So we'll just work from the rightmost here first, B. So for B, if you put into your calculator, you should have 1011. This is for B. And for the 6 here, we should have 0110. So this is representing 6 in binary. And last but not least, you will see that 3 is just 11. So all in all, you should have this as your answer. That's it. The next question is all about the 2's complement representation. Okay, so we have worked out these questions, similar questions in the MC question. So I'm not going to explain too much. 82 is a positive number, positive. So if we want to write down this number in its 2's complement representation, because it is a positive number, we will say that the sign and magnitude representation is already its 2's complement representation. So work it in your calculator. Just make 82 into binary, right? So let me just show you. How to work out the conversion. So mode and then 3, and be careful, this is in binary now. We are given with a decimal number, so make a decimal mode here first, D, and then we just put down the number 82. So here it is the 82, and then we just make the binary here. So this will become the binary representation of 82, and because it is positive and we want to write it in 8 bits, so make sure that here it is 8 bits. So 1, 2, 3, 4, 5, 6, 7. We are missing 1. Here we will have the 0. Okay, so here it is a 0, 1, 0, 1, 0, 0, 1, 0. So this is in its 2's complement representation. So we'll write it down. So the answer is 0, 1, 0, 1, and then 0, 0, 1, 0. Okay, so this is the answer. So for question D, we are still working for the 2's complement representation, but this time with the negative. Okay, so if it is negative, you can also make use of your notes. Okay, look at the method, how we do it, the conversion for the 48. So first of all, we can just omit the negative sign. We just think about what is 48. Okay, so 48, if you just go to the representation of the numbers in your calculator, you should get something like this, right? Here, 48, we'll do the same thing here, decimal, and then 48, right? We think about 48, and then I just make it into the binary and make sure that it is in 8 bits. So 1, 2, 3, 4, 5, 6. I'm missing 2 more in front. So that should be 0, 0, 1, 1, 0, 0, 0, 0. So just write it down. 0, 0, 1, 1, and then 0, 0, 0, 0. Okay, so the first step is to make the 48 into the binary. Okay, and then the negative tells you that you have to do the flipping and +1. Okay, so I will just do it one by one here. So first of all, you invert the digits of the above expression, so it will become 1100, 1111, and then you do the +1 here, which will become 1101, 0000, right? So after the conversion here, you will see that this is already the 2's complement representation of negative 48, and therefore just write in case to make it clear. Negative 48 is equal to 1101,0000. Okay, so if you have something not clear, just refer to the notes here. Okay, just refers to the notes in the lesson. So this is for the representation of negative 48. So the last two questions are asking you for the writing down the largest number for an 8-bit 2's complement representation. So the first question is very easy, because if we are finding for the largest number, that means that number should be positive. And we know that already, for positive number written in 2's complement representation, it is exactly the same as the sign magnitude representation. Okay, so imagine we have 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, right? We will just have the sign magnitude representation, the first bit to be the +1, right? So always it should be 0. And then after that, here will be the magnitude, right? Magnitude. Okay, and we want to have the largest number, so you will fill in all the spaces by as many ones as you can here. So in other words, the largest number in this representation will be 01111111. And they are asking for the denary value, so you just work out in your calculator. I'm not going to show it out. So it will be the number 127. So the last question you have to think in a different way, because it is a quite difficult question. Okay, so the F question is asking you for the smallest number, okay, which means the most negative number that you can make it by using the 2's complement representation in 8 bits, right? So first of all, you should know that in these 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, right? The first bit, okay, here, right, is already assigned to 1 already. Since in the first question, E here, you can see for positive, it is 0, right? So the only way for you to make a negative is to make this 0 into 1. So 1 means the negative in this case, and therefore this is already fixed to 1. So the thing is about here, the remaining 7 bits here, right? So you have to jump into the number of patterns here first, because here we have to ask a question: how many different patterns can you make by these 7 bits? Okay, because if you can answer for this question, you should know about what kind of number here you should have for your answer. Okay, so here we have 7 bits, so that means for every bit we have 2 different representations: 0 or 1, 0 or 1, 0 or 1, 0 1, 0 1, 0 1, 0 1. Okay, so we have 7 bits for different kind of combinations of 0 and 1. So all in all, we'll have 2 to the power of 7, and that should be 128. Okay, so in this case, you will say that for these 8 bits, the most negative one you should have is negative 128. Okay, the most negative number should be negative 128.